Hello and welcome to the video. In this video I'm going to be solving some questions from the chapter real numbers, and I'm picking up questions from RS Agarwal 1B exercise. The exercise has a lot of questions, and in this video I'm focusing on solving these 4 questions only. I'll probably make a series of videos in which all the other questions could be solved. As of now, I will begin with this video and slowly we'll look at the other ones. So most of the questions in exercise 1B is dependent on Euclid's division lemma. So what does Euclid division lemma state? It simply states this, that for any two positive integers a and b, there exists a unique whole numbers such as q and r, such that a is equal to bq plus r. This is not very difficult to understand. It's just this much. Let's say I'm taking two numbers. Let me consider, let's say 24, and let's say another number 5. Okay, so if I'm dividing 24 by 5, what am I going to get? 2 5 4s are 20, and the remainder is a 4. So now the dividend, which is 4, this here is the dividend, this here is the quotient, this is the divisor, and this here is the remainder. So Euclid's division lemma, you already know this from the chapter remainder and factor theorem of 9th standard, that dividend is equal to divisor into quotient plus the remainder. That's exactly what this is. Plus 4, where 4 is again the remainder. So when I'm dividing a number, any number, by a 5, if I'm dividing any number by a 5, the possible remainders are going to be either 0, 1, 2, 3, and then a 4. I cannot have 5 and above 5, because if I did, then my division process will continue. And that's why you see this condition that the remainder has to be between 0 and a number less than the divisor itself. So remember that. So if in case I'm dividing, let's say by a number 7, so what's the possible remainders? The possible remainders are going to be 1, 0, 1, 2, 3, 4, 5, and 6. You can check that. You will not get anything more than that. Okay. If in case it's the remainder is a 0, then you know that the number is a factor, which is exactly what you learn in remainder and factor theorem also. What do I mean? Let's say, for example, I'm dividing, let's say 30 by a 5, then 5 6 is 30. The remainder is a 0, which means 5 is a factor of 30. There is no remainder. Okay. So keep this in mind. A is equal to bq plus r, and 0 less than or equal to r and less than or equal to b. We're going to be making use of these to solve the questions which is in the exercise. Now, along with that, you need to know another aspect, which is how to find the HCF of two numbers and the LCM of two numbers, and the meaning of HCF and the meaning of LCM. HCF simply means the highest common factor. Now, when you're listening to this, you may feel that, HCF and LCM is something that you learnt in like 4th, right? But believe me, there are people I've met in 12th standard who do not understand the conceptual meaning of the highest common factor and the least common multiple. This is the least common multiple. So let's take two numbers. Let's say I'm picking up a number 12, and I'm going to pick up another number, let's say 8. So what are the factors of 12? When I say factors, these are the numbers which divide 12 completely. So the factors are going to be 1, 2, 3, 4, 6, and 12 itself. These are the factors of 12. So what are the factors of 8 now? The factors of 8 are going to be 1, 2, 4, and 8. Now out of these, I'm looking for the common factors. This is a common factor, this is a common factor, so is this a common factor? And which is the highest common factor? The highest common factor, or the HCF, of 12 and 8 is simply a 4. Now that's the meaning of HCF, alright? So what's the meaning of LCM, right? So what I'm going to do here is to write the multiples of 12. Remember the difference between the multiples and the factors. People do get confused about it. So the multiples of 12. 12, 24, 36, 48, and then 60, 72, and this goes on. What are the multiples of 8, right? The multiples of 8 is going to be 8, 16, 24, 32, 40, and this continues. Now in this, I'm looking for the common multiples, right? I'm looking for the common multiples. As of now, I find only one common multiple. If I'm going further like that, I'm sure to have more common multiples. For example, here the next number I get is a 48, so 48 is going to be my next common multiple. So what is the least common multiple? LCM, 24. Okay. What do we understand from this? We understand that HCF is lesser than the numbers given and LCM is greater than the numbers that's given to us. HCF will divide the numbers given to us. So 4 divides 12 and 4 divides 8. So the HCF will divide the numbers given. Whereas the LCM is the other way around. The numbers given divide the LCM. So in this case, it's 12 that divides 24 and it's 8 that divides 24. So it's the other way around. And the LCM is always higher than the numbers given. HCF is lower than the numbers that's been given to us. Another, formula you can say that you can remember of this chapter is this. The LCM into HCF is always going to be equal to A into B. So this is the meaning of HCF and LCM. I'm going to connect all of these when I'm solving questions, so please have patience while I explain this to you. Obviously, you're not going to do this method to find the HCF and LCM in your 10th standard. You're going to have a different method. What is that method? The method is simple this. You factorize 12, you prime factorize 12. So when you prime factorize it, you're going to get 2 to the power of 2 into 3. And then you prime factorize 8, which is going to give you 2 cubed. So what are you going to do for HCF, which is the highest common factor? For the HCF, you're going to take the common multiples or the common factors. In this case, the common factors are 2, and therefore I'm going to take 2, and then I'm going to take the least power. The least power here is a 2 again. What am I going to do for LCM? For the LCM, I'm going to take all of them, all the factors, and then I'm going to choose the highest powers. And this here is going to give me a 4, and this here is going to give me a 24, which is what we got here. So this is a method of finding a HCF and LCM of the two numbers. So let me pick up the first question. So the question says, find the largest number which divides 438 and 606, leaving a remainder of 6 in each case. So you already know that the number that we are looking for is going to be lesser than the number given to us. All right? Find the largest number which is dividing both of them with a remainder. And therefore, when I know that the number that I'm looking for is a lesser number, I by default know it's the HCF that I'm looking for. So what am I going to do here? I'm going to say, let the number be some number b. some number b. So what does the question say? I'm supposed to be dividing 438 by this particular number b, and also 606 by this particular number b, and the remainder in both the cases should be a 6. I don't know the quotient. The quotient in both the cases, let's say this is a q1 and this is a q2. This is a q1 and q2. So if I'm using Euclid's division lemma, I can certainly write 606 as equal to b q2 plus the remainder, which is 6, and 438 as equal to b q1 plus the remainder 6. Now the moment I transpose both of them to the left hand side, here in this equation I'm going to have 600 is equal to b q2, and from here I'll have 432 is equal to b q1. So what does this tell me? It tells me that b is a multiple of 600 and also of 432. All right, which means b is a HCF of 600 and 432. So how do I find a HCF now? Well, let's prime factorize it. So if I'm prime factorizing 600, I'm going to have 2 into 3 as 6, and then 100 is 10 into 10. So this is for 2 into 5 and 2 into 5. So I'll have 1, 2 and 3 2's multiplied with 1 3 multiplied with 2 5's. Next, let's factorize 432. So I start with the 2, 2 to the 4, 2 1s are 2, 2 6 are. I know this is 6 cube. So this is 2 into 2 into 3 into 2 into 3 into 2 into 3. So 1, 2, 3, 4 2's multiplied with 1, 2, 3 2's, 3 3's. So what am I looking for? I'm looking for the HCF. So the highest common factor of 600 and 432 is, you take the common multiples or common factors, and then you take the least powers. So the least power of 2 is a 2, least power of 3 is a 1. So what is the HCF here? 4 3s are 12. So 12 is that particular number. All right. So listen to this, guys. I mean, 12 divides 600 completely. 12 also divides 432. So what's the remainder here? The remainder here is 0, and the remainder here is also 0. But if I increase this number by 1, the remainder is going to be a 1. And here also, if I'm increasing by 1, the remainder will become a 1. If I increase this number by another 1, the remainder becomes a 2. Same happens here also. So 12 is giving me the same remainders. So I need a remainder of 7, which means I'm going to be a remainder of 6, which means I'm going to be adding a 6 to 600, which is what I get here. Just another way of understanding this. All right. I hope you got the idea as to how we are going to be using Euclid's division lemma to solve questions of this sort. All right. I have tried to look at solutions online to see if there is, a different way that other educators are using to teach this. What I did found was most of them are not using Euclid's division lemma. I think this question is understandable and explainable well if you're using Euclid's division lemma. Let's go to the next question. So the question says, find the largest number which divides 320 and 457, leaving a remainder of 5 and 7. Again, we're going to be using look at Euclid's division lemma itself to solve this question. So I would like you to pause the video and try to do this all by yourself. I am going to solve it, but I want you to attempt it before you can actually look at the solution that I put up. Okay, so let's go with Euclid's division lemma, right? So I need a number. So I'm going to say let the number be a b. What is it saying? Find the largest number which divides this and this, which means I'm looking for the number which is smaller than the numbers given to me. And therefore, if I'm looking at the numbers which are smaller than the numbers given to me, then it's basically the HCF. So what am I doing here? I'm dividing 320 by b, and I'm looking for a remainder of 5. And I'm taking the same b and I'm dividing 457 and looking for a remainder of 7. Wonderful. So let's say in both the cases I take the quotient as q1 and the other quotient as q2. Can I then say that 320 is equal to bq1 plus the remainder 5? As per Euclid's division lemma, a is equal to bq plus r. Can I then say that 315 is equal to bq1? 315 is basically 320 minus 5. Can I also say that 457 is equal to bq2 plus 7? So when I transpose it, I get 450 is equal to bq2. So b is a factor of 315 and also of 450. Which basically means that b is the HCF of 315 and 450. Let's quickly find out the HCF of it. $450, again I'm going to start with the 3. So the prime factorization of 315 is 3 square into 5 into 7, and then I have the prime factorization of 450 as equal to 3 square into 2 into 5 square. So what's the HCF of 315 and 450? Well, you take the least, the common factors first, and then the least powers. So you get 9 5s are 45. So 45 is that number, which will divide 320 and also 457 with a remainder of 5 in this case and with a remainder of 7 in this case. I mean, you can do a verification if you want to. Let's go ahead and do that. So 45, 320, 28, 315. There you go. The remainder is a 5. What about 457? Well, 457 is much easier because it's 10 times 450. 7 is the remainder. So that's usage of Euclid's division lemma again to solve the same question. Let's go to the next one now. Find the least number which when divided by, okay, so and so leaves the same remainder, 7 in each case. Now I want you to think about it, all right? Are we looking for a bigger number or are we looking for a smaller number? Logically think about it. I'm looking for something which when divided by these 3 numbers. So 35 is supposed to divide something. 56 is supposed to divide something. 91 is supposed to divide something, which basically means the number is greater than all of these numbers. And if the number that we're looking for is greater than all the numbers given to us, then we basically go for the LCM. Okay? What is the factorization of 35? So 35 is 5 7s are 35, so I can directly write that. And what about 56? Well, I'm going to factorize that. 2 2s are 4, 2 8s are 16, 2 1s are 2, 2 2s are 2 4s are 8, 2 7s are. So that's 2 cube into 7. 91 is a prime number. All right. 91 is multiple of 13 and 7. 7 3 is 21. 91. So this is going to be 7 multiplied with 13. Okay. So the LCM of 35, 56 and 91 is simply equal to 2 into 5 into 7 into 13. What are the highest powers? Powers of 2 is 3, powers of 5 is a 1, power of 7 is a 1, power of 13 is also a 1. So what does this mean? It simply means that 35 completely divides 3640, 56 also completely divides it, 91 also divides it, which means in all the three cases, when I do this division, I will get the remainder as 0 for sure. Even 56, the remainder will be 0. So if I had to write this in Euclid's division lemma, what would I do? I would write as equal to 35 into 8 into 13. Well, I'm just going to write it as Q1. 3640, and that's going to be equal to 56 into Q2. And 3640 is going to be 91 into some number Q3. And you see, in all these cases, I have a remainder of 0. What's the question saying? I need a remainder of 7. So I'm going to add a 7 in all the cases. How am I going to do that? Well, add a 7 here, add a 7 here. Remainder of 7, add a 7 here, add a 7 here. So add a 7 here, add a 7 here. So what is the required number? The required number is 3647. That's the number which, when divided by 35, 56 and 91, will give you the same remainder, which is 7. Let's go for the next question. Again, every time I do this question, I want you to try and do it all by yourself, all right? Without you actually putting in effort to do the question, you may find it difficult to solve in the examination, all right? You may watch this video 100 times, but if you're not going to put in the effort to do it by yourself, you will find it difficult, all right? So the last question that I'm going to be doing for this video is the 18th one. There's a mistake in the question, the typing mistake in the question. Find the smallest number which, when, this is divided by. Okay, this is a divided by, this is a mistake. I'm going to paste the new question, the correct one. 8 and 12. This is that question. Find the smallest number which, when divided by 32 and 28, leaves the remainder so and so. So obviously, when I'm looking for a number which is divisible by something, I'm looking for a number which is bigger than the given numbers, greater than the given numbers. And therefore, I'm looking for an LCM. So what is the LCM of 28 and 32? Let's simply find that out. This will be a bit of a longer explanation, okay? So please have some patience. I'm going to try and explain this as much as possible in a much simpler way. But listen, hear me out. So now 28, if I'm factorizing it, I'm going to get 2 1s are 2 4s are 2 7s are. So this is 2 square into 7. 32 is 2 to the power of 5. We know this. So the LCM of 28 and 32 is going to be 2 and 7 with the highest
powers, which is 5 in this case. So 32 into 7, so 7 2s are 14, 7 3s are 21, 22. So I get the number 224. If you try to look for solutions for this, most of them they do this. They take a 28, subtract a 8, they get a 20, they get 32, subtract a 12 from it, which is the remainder, they get a 20. Take this 20, subtract it from here, so you get 224 minus 20, which gives you 204, and they conclude that 204 is a number. If you're ready to memorize this particular question, where he's looking for an LCM with different remainders, this is the process. Okay? But if you are looking for conceptually understanding as to why this is, you can continue with the video. Now, what's the remainder when 224 is divided by 28 and 32? Remainder is 0 in both the cases. What if it is 225, which is 224 plus 1? Right? This is 224. When I say 225, in both the cases I get the same remainder, which is a 1. What about 226? I'll get the same remainder, which is a 2. Understand, I'm simply adding a number, right? And the remainders are coming up. So if you see, if the number is increasing, the remainders are the same. The remainders are not going to change. Until when is the remainders not going to change? The remainders are not going to change until I add a 27. So 224 plus a 27 is going to be 251. So until 251, the remainders are going to be the same. But the moment I go to 252, the remainder will become a 0. Why? Because 252 is completely divisible by 28. However, it's not divisible by 32, and therefore the remainder is going to be a 28. What about 253? Well, remainder 1, remainder 29. So 254, remainder 2, remainder 30. 255, remainder 3, remainder 31. Now what happens? 256, remainder 4, remainder 0. Remainder 4 and remainder 0. So if I continue further, and I'm looking for a remainder of 8, so I'm going to be adding another 4 to this, so I get a 260, where the remainder is going to be a 8. Whereas in this case, when I'm adding a 8 to it, the remainder is going to be how much? A remainder is going to be a 4. So here I will start getting different remainders. Okay. Continuing further with this pattern. Okay. The next multiple of, what is that number? 28. The next multiple of 28. There's going to be a different remainder, and this remainder will again change. So this will keep happening. All right. And the cycle will keep continuing. And there will come a point where the remainders are going to become 8 and 12. Okay. But if I went backwards, when I go backwards, 20 of 224. This process is happening when I'm going forward. But the moment I go backwards, I will have different remainders again. Because if I go for 223, the remainder from here will be a 27. And the remainder from here will be a 31. When I say this and this, I basically mean the numbers to 28 and 32. So 27 and 31. Right? So if I go for 222, then the remainders are going to be 26 and 30. So if I keep going backwards like that, at 204, here the remainder is going to be a 8, and here the remainder is going to be a 12.
I wouldn't recommend a child or a student of 10th standard to understand this concept and reciprocate this in the examination. No, I wouldn't want them to do that. It'll be unfair of me to ask them to understand this and replicate that in the exams. What I would suggest is basically what your teacher or any other source tells you. Find out this. If the remainder is the result is 20 itself, take the LCM, subtract 20, move on. You don't need to break your head on this. If you want to conceptually understand as to why is this happening, well, this is your explanation. Okay? So, in this video, we have looked at 4 questions from the chapter Real Numbers, exercise 1B of RS Agarwal. We've used Euclid's division lemma to understand these questions and to solve them. Euclid's division lemma simply talks about A is equal to bq plus r, where the remainder is 0 less than or equal to r and less than the divisor b. And then we spoke about what is the meaning of HCF, what's the meaning of LCM, how to find the HCF and LCM. And then we started off doing the first question, which, again, usage of A is equal to bq plus r. All right. Interesting questions these are. Find the largest number, leaving the remainders 5 and 7. Again, usage of bq plus r. It becomes much easier to understand and to, get the solutions for this. The last question was a bit tricky and a bit lengthy. As I said, remember the short form, apply it and move on. You don't need to break your head on this concept, but if you did, well, good job. Good job. All right. That's it for this video. I think we're going to end this video with this. Thank you very much for your patience. If in case you have any questions, you can always leave a comment and I'll try and respond to that. Thank you for your patience again. Goodbye.